This is a series of solutions for the paper 2 questions in the IBDP Maths Analysis and Approach higher level exam that was held in November 2024. This is a calculator use exam. So most of the problems requires you to use calculator in order to find certain variable values to obtain approximation. So the first question, consider the function f of x equals 11 square root of x negative 2x minus 11, where its domain is restricted to be between 0 and 20. The first question simply asks to find the value of f of 0 and f of 20. If we put 0 here, these two terms vanish because square root of 0 is 0 and negative 2 times 0 is 0. The only these terms survive. So negative 11 f of 0 is negative 11. And if you put f of 20, you get 11 times square root 20, negative 40, negative 11. So this one gives you 22 square root 5, because 20, square root 20 is 2 root 5, negative 51. If you put it in a calculator and find the approximate values, you get that to be negative 1.807. In this question, in the later parts, it asks to find the two roots of f of x equals 0 and also sketch the graph of y equals f of x on the following grid. So we found that f of 0 equals negative 11 and f of 20 is equal to negative 1.807. So let's mark those points on the graph where you have to sketch. So here, this is f of 0. This point is the coordinate of f of 20. Now we need to find the roots of this polynomial at 0. So let's go ahead. So first we assume that square root of x equals t. So we kind of do a change of variable in order to proceed. So then f of x equals 0 turns to 11 times t, negative 2t squared, negative 11. If you solve this quadratic equation, you get 11 over 4 plus or minus square root 33 divided by 4. And since we know that x square root x equals t as we assumed, this implies x is t squared. So whatever value we got for t here, we have to square it in order to get the corresponding values of the variable x. After doing that, we obtain the two values of x for which f of x equals 0. So 1.726 and 17.524, these are the 2 points where f of x equals 0. So this is roughly 1.726, and here this is roughly 17.524. Now comes the point where you have to sketch the graph. So we see that at f of 0, the value is negative 11, f of 20, and we also know the two roots, which means here the function value is 0. So the graph is probably going to look like this in this part from 0 to 1.726 and from 17.524 to 20. What happens in between is still a little bit of confusing part. So we still are not sure. Probably it goes up, then comes down. But in order to calculate how far up it goes and where is the maximum and the turning point of this curve, we have to calculate its derivative. So if we calculate y prime and set it to 0, we will find the x max, that is the value of x where y is maximum, and if we put x max into the function of y or f of x, we will get the function's maximum value. So let's proceed that. In part C, we set f prime of x. F prime of x will give the first value. The first term will give me 11 divided by 2 square root of x, negative 2 equals 0. So 2x just gives 2, and 11 square root x gives 11 divided by 2 square root x. So this tells us that x equals 11 over 4, or x equals 11 over 4 whole square, 7.562, these values. So at x equals 7.562, the function reaches its maximum. That is because f double prime of x is actually less than 0. And at that point, the highest value of this function is 4.125. So here now we can complete the sketch like this roughly, where this is the xf or x max, comma f of x max. So let me just quickly go through those numbers. Question number 2 asks to find the coefficients of x to the 6 in the expansion of 2x minus 5 to the power 9. So this is a classic application of binomial theorem. So we have to use the expansion for a plus b to the power n. So let's see the formula once. So here you have a plus b to the n, which is a sum over k equals 0 to n, and then a to the k and b to the n minus k, n factorial divided by k factorial, n minus k factorial. Just to remind you, any integers factorial means start from that number, you reduce the number by 1, and so on. Keep multiplying the numbers until you reach 1. So in this case, we have 2x minus 5 to the power 9. So if we look at the term 2x to the power 6 and negative 5 to the power 3, that corresponds to k equals 6. So that term for k equals 6 would be 9 factorial, which is n factorial, divided by 6 factorial, which is k factorial, times 3 factorial, which is n minus k factorial. So we have n 9 factorial divided by 6 factorial times 3 factorial times 2 to the 6 negative 5 cube. So the ratio of 9 factorial by 6 factorial is simply 9 times 8 times 7, because the rest of the 6 factorial cancels with the 6 factorial in the denominator. And 2 to the 6 is 32. So this becomes 987 by 6, 3 factorial, 2 to the 6 with a negative sign, 125 is 5 cube. So if we go ahead and find that value, as you can see here, 9 factorial by 6 factorial times 3 factorial, 2 to the 6, negative 5 whole cube. We can just straight ahead put in the calculator, and the answer is negative 672,000. Question number 3. A discrete random variable x has the following probability distribution. So the variable can take these four values 3, 5, 8, and 11, and corresponding probabilities are k by 20 times this variable value. So first of all, find the value of k and then find expectation of x. So for the first question, we just need to use the simple principle that the sum of the probabilities of these variable values have to be 1. So sum over probability of x, sum over x is 1. So in this case, this is kx divided by 20. So let's compute what it becomes when you do it for 3, 5, 8, 11, and sum them up. So we have 3k by 20, then 5k by 20, 8k by 20, and 11k by 20. So 11 plus 8 is 19, plus 5 is 24, plus 3 is 27. So this is 27k over 20, that is here. So this is the total probability, and this must be equal to 1. So if you can just easily find the value of k to be 20 divided by 27. So that's the answer of the first part. Now, in order to find the expectation value of x, instead of summing the probabilities, each time you have to multiply the corresponding value as well with the probability. So probability of x, kx divided by 20. You also have to multiply the value of the variable to this probability to get the expectation value. So this is k over 20 times x squared. And here we sum over again 3, 5, 8, 11. So we find out that k equals 20 divided by 27 in the first part. We can put that here, and then k over 20 becomes 1 over k over 20 becomes 1 over 27. So we have 1 over 27 times x squared, that is summed over the values 3, 5, 8, and 11. If you calculate this quantity, you get 8.111 as the answer. So question number 4. The following diagram shows the cross-section of the roof of a house. So this is like a triangular shaped roof. The cross-section is symmetrical about the vertical line through points A and B. So then it asks to find the size of BAE, the angle BAE. The gradient of BA is given to be 7 over 12. So let's see, the gradient of this straight line is given, which is 7 over 12. So let us say the horizontal line makes an angle theta. So in that case, tan theta is 7 over 12. From here through calculator, you can find out what would be theta by just applying arctan or tan inverse on 7 over 12. Now it asks to find out BAE. If you just extend this straight line and draw another straight line that goes down like this, we can see that the sum of theta and the sum of BAE is 90 degrees. Since we have found the value of theta, we can easily subtract that from 90 degrees to get the angle BAE. So let's just see what the answer comes out to be. So firstly, theta is tan inverse 7/12. This is 30.3 degrees. And the angle BAE is 90 minus 30.3, which is 59.7 degrees. So this question continues. So now it asks that a builder requires the lengths of the sides BA and CE. So BA and CE. The builder has the following measurements. So A, B, C, and BCE are both 90 degrees. So this one, this angle, and this angle is 90 degree. And DC equals 50 centimeter, which is written here. And BC equals 30 centimeter. And DF, this long length, is 700 centimeter. So firstly, if you draw a perpendicular just extending AE, we know that the roof is symmetric across the vertical line. So when it touches DF at this point, the perpendicular line, it divides the length into two equal parts, each of 350 centimeter length. And if we draw another perpendicular between E and G, so from E, we draw a perpendicular on VA straight line, this line, then we can see that BG would be equal to CE because then BGCE is a rectangle. So what we need to find is AG to find the difference between BG and CE. So let's go ahead and see the solutions and discuss it. So to start with, we have found the angle here to be 30.3 degrees from the previous problem. And DE then, from here till here, DE is 350 centimeter divided by cosine of 30.3 degrees, because DE 350 by DE is cosine 30.3 degrees. So if you want to find DE, you have to bring the cosine 30 degree down. So next, CE equals CD plus DE. So CD is given and DE we just figured out using trigonometric ratios. So then CE can be found. CE is 405 plus 50. So 405 coming from this 350 divided by cosine 30.3 degrees. So that plus 50 is CD. So total we get around approximately 455 centimeters. Here actually all lengths are given in centimeters and there is no decimals. So it's all given in integer centimeters. So all answers must be in the same format, that is rounded off to nearest integer. Now we have to find BA. So as we said earlier that BG is equal to AG, AG CE, BG equal to CE because BGC is a rectangle and all we need to find is AG. So in order to do that, BG equals CE as I said, and GA equals GE tan 30.3 degrees. So this angle here is 30.3 degrees. So GA divided by GE is tan 30.3 degrees. If we find that value, we can find BA as BG plus GA. But GE is nothing but BC because BGC is a rectangle. So that gives us GA to be the value of BA, which is 473 centimeter if you add the two contributions. So here we used the fact that the value of BG is equal to value of CE. CE we found about 455. So in this case, we have written it in one decimal places because it is getting like added by another decimal point. So that might change the final answer. So once we do the put the value of BG, we need to find out GA. So GA is GE times tan 30.3 degrees. So 30 centimeter times tan 30.3 degrees is GA. So if you put that, this comes out to be 17.5. And if you sum them and round off to nearest integer, the total sum becomes 473 centimeter. Question number 5. Consider the function log base 10, 4x squared negative rx plus r minus 1, where x is a real variable. Find the possible values of r. Basically, it means that whatever is there within the log operator, that has to be positive. So we need 4x squared minus rx plus r minus 1 to be positive or semi-positive for all x real values. Given that constraint, what should be the range of values of r that are allowed? So there are two ways to do it. Let's do them one by one. So first, we need to have this inequality. So if we can show that when the function 4x squared minus rx plus r minus 1 is greater than equal to 0, even when at its minimum with respect to x, then it is suffices to say that 4x squared negative rx plus r minus 1 would be greater than equal to 0 for all values of x. So to do that, first we take the first derivative, which is 8x times 8x minus r, and we take the second derivative to make sure that this is indeed minimum. So the second derivative being 8 greater than 0. So that means it is a minimum. So the minimum value is at r over 8. So now if we put the value r over 8 in the functions, then we get an expression entirely in terms of r. So we have r's negative r square over 16 plus r minus 1. Now we want this quantity to be greater than equal to 0. If we can have that, then for all possible values of x in real values, this expression will be greater than equal to 0 and the log will be well defined. There is another way to arrive at this inequality containing r, and that is to first complete the square of ax square plus bx plus c. So this is an ax square plus bx plus c form of polynomial, so quadratic polynomial. We can complete the square and make sure whatever is left is greater than equal to 0 after the square, because the perfect square is going to be positive, semi-positive anyway. So whatever is left, if that is also semi-positive, that ensures that the polynomial will be semi-positive always, overall. So here C is r minus 1, the constant term without the x variable, like the constant coefficient. B is negative r, the coefficient of x, and a equals 4, coefficient of x squared. So c minus b squared over 4a is greater than equal to 0 that we got here. If x equals r minus 1, negative r squared over 16. So from here, this is actually same as this inequality, what you got, historic equivalent. So either using calculus, we can find the minimum and force it to be greater than or equal to zero, like on the left-hand side. And on the right panel, as you see, we can also, like in this case, since this is a quadratic polynomial, make a perfect square, and whatever is left, other than that, we can enforce that to be greater than or equal to zero. So both gives the same condition on R. And so if we just find the constants, like this constant enforced values for R, we get these critical values. So 8 minus 4 root 3 and 8 plus 4 root 3 are the two roots of this polynomial. And so their product has to be less than or equal to 0. Starting from here, we have actually changed side because here r square came with a negative sign. So now here it has positive sign. So it must have been, we have changed sides. So greater than equals becomes less than equals. So this means that R has to lie between 8 minus 4 root 3 and 8 plus 4 root 3. So 8 plus 4 root 3 is of course greater than 8 minus 4 root 3. And so R resides between that smaller and the larger one. If that is the case, then this factor, which is like R minus alpha minimum and R minus alpha maximum, if I write it like that, maximum being 8 plus 4 root 3 and minimum being 8 minus 4 root 3, then one of these factor, specifically R minus alpha minimum, will be negative, and R minus alpha max, sorry, R minus alpha max will be negative, and R minus alpha minimum will be positive. So if you multiply them, their product will also be negative or less than equal to 0. So this is the range of values that are allowed for R in order to have all possible real values of x to give 4x square minus rx plus r minus 1 to be greater than 0. And hence the log is well defined. Question number 6, a continuous random variable x has probability density function which is given by f of x equals 1 over 5 for x lying between 0 and 2, and for the domain 2 to 8, it's lying between 2 to 8, the function is given by negative x over 30 plus 4 over 15, otherwise it is 0. So find the expected value of x, given that expected value of c minus 2x equals 0, where c is a constant, determine the value of c and find the median of x. So these three problems can be solved just by applying the definition of, for example, expectation of x and the median of any random distribution. So let's go ahead and see how each one works. So first, we have to calculate expectation of x. So the formula for that is you multiply the value of x. Correspondingly, you multiply it with its probability density function, and then you integrate over the entire domain. In this case, the domain is divided into two parts, from 0 to 2 and from 2 to 8. So from 0 to 2, the probability density function is just 1 over 5. And this value x is for multiplying with the value itself to find the expectation of x. Here it is x by 30 minus 4 over 15, but there is a minus sign taken out. So it is actually negative x over 30 plus 4 by 15. It has been written this way just for convenience of the calculation of integration times x and then dx from 2 to 8. So if we carry out this integral, we have this x squared over 10. So x integral is x squared over 2, which becomes x squared over 10. And then x squared over 30 becomes x cubed over 90, because x squared is x cubed by 3. And x is just x squared over 2. So this becomes 2 over 15 x squared. Now this can be evaluated very easily by putting the limits of the upper limit minus lower limit. So basically in this function, you have to put this function's value at x equals 8, and then minus this same expression evaluated at x equals 2. And similarly here also 2 and minus 0. So if you calculate that, it comes out to be 14 over 5. Now the next part asks, if expectation of c minus 2x equals 0, then what is the value of c? So expectation is a linear operator. So if I have c minus 2x, it is expectation of c minus expectation of 2x. Now, since c and 2 are just two constants, expectation of c is just going to be c, and this is going to be negative 2 times expectation of x. So if this is equal to 0, then c is simply 2 times expectation of x, which is 2 times 14 over 5 that was found in the previous part. So this is 28 over 5. Now in the part C, we have to find the median. So median is the value of the random variable such that up to that value, if you integrate the probability density function, you'll get half. So first let's since our domain of the random variable is divided into two distinct parts, let us calculate over the first domain what the total probability is. So over the first domain from 0 to 2, the total probability would be 2 over 5. So 2 over 5 is like it's less than half. So that means xm is greater than 2. So we have to find xm between 2 and 8. So we have to find the following integral. Let me erase this. So from 2 to xm, 2 to median, dx times this is the f of x, the probability density function, that should be equal to half minus 2 over 5. Why half minus 2 over 5? Because we have already accumulated 2 over 5 probability amount from 0 to 2. So we now need to accumulate only 1 over 10th probability from 2 to xm to find xm. So we do that. We carry out the integral. And what we have is 4x by 15 minus x squared over 60 from 2 to xm. It turns out to be negative 7 over 15, negative xm squared over 60 plus 4xm over 15 equals 1 over 10. If we put that in the calculator, we would find that xm comes to be around 2.523. So that would be the median value. It's greater than 2, but just by a little bit. Question number 7. A self-service sushi restaurant has a row of 12 available seats as shown in the following diagram. The three friends decide to go to the restaurant for lunch. Find the number of possible ways they can be seated in this row, and if they do decide not to sit together as a group of three. So that's the first part. So let's see how to calculate that number of ways. So number of ways, if we can find number of ways that they can sit in a group of three, and number of ways that they can sit in general without any restrictions, and subtract the first number from the second number, we will get all possibilities. We will cover all the possibilities when they do not sit in a group of three. So let's try to understand the number of ways that they can sit in a group of three. So if there are 12 seats, and if they are always sitting in a group of three, then we can as well say that there is a big seat, and this big seat is movable. And here there are three factorial possible ways of within them, like permuting who sits on the left, who sits on the right, who sits in the center. So there are 3 factorial ways to rearrange themselves within that group of 3. Now this group of 3 can sit in 10 different ways because we had initially 12 seats, but now there are 3 of them are occupying 1 seat in a way. If we perform that transformation, that 3 of them sit in a big chair, 3 of them sits on a big chair, then now we have 10 seats because the 12 minus 3 plus 1, that would be the number of chairs, so that would be 10. So this group of 3 can be seated in 10 possible chairs or big chairs in the group. So for each of those possibilities, they within themselves of the group of 3 can rearrange themselves in 3 factorial ways. And in general, the total number of ways to sit is 12 times 11 times 10, simply because the first person can sit in 12 different seats. And given that for each such possibility, the second one can be seated in 11 ways, the third one can be seated in 10 ways. So now we have found the number of ways of sitting just without any restrictions and sitting in a number of group of 3. So if we do the subtraction, we will obtain the number of ways that they do not sit in a group of 3, and it turns out to be 1260. So we have this is 132 times 10 comes from 12 into 11 is 132, and then there is this 10. This is 10 into 3 factorial is 6. So this is 6, so this is 60. So 32, 1320 minus 60 is 1260. So let's see the next part of this problem. The next day, these people are joined by 3 additional people in the same restaurant, and they sit in the same row of 12 seats. Now they want these 3 friends, Anvi, Vanya, and Parita. They decide to sit next to each other as a group of 3. Find the number of possible ways that these 6 people can be seated. So the other 3 has no restriction; they can sit anywhere. But there is a 3 person who wants to sit in a group of 3. So we just found out that for them to be seated in group of 3, when the all the seats are available, it's 10 times 3 factorial. Now for each such possibilities, there are how many seats left? Because they have occupied 3 seats, there are 9 seats left. So the way the fourth person can sit in 9 ways, the fifth person in 8 ways, and the sixth person in 7 ways. So that would be the total number of ways these persons can be seated. So let's see how it comes out. So yeah, so 10 times 6, as we found out, is the way they can be seated in a group of 3, and 5 not 4, which is 9 times 8 times 7, is the number of ways that the other 3 people can sit after this group of 3 has been seated. So this comes out to be 30,240 ways, which is a pretty big number. Question number 8. Given that W is a complex number, prove that W star is modulus of W or magnitude of W squared. The two complex, so that's the part A. So this is actually pretty easy to prove. So you can just assume that a W is given by x plus iy in the Cartesian coordinate form. So W star would be when its imaginary part becomes just have the opposite sign. So this is x minus iy. And when you multiply W times W star, you have x plus iy times x minus iy. If you multiply them term by term, you get from here x square, from here negative ixy, from here another positive ixy, and from here you get I square y square with the negative sign. So you get negative I square y square, but ixy and iy cancel each other. But negative I square, as we know, is plus 1. So we get eventually x square plus y square. So if in the Cartesian coordinate form, if the point is at x comma y, x square plus y square is the length of its vector from the origin and its magnitude square. So that proves the first part. So there are actually another way of showing this using the polar coordinate form. If you write w as r times e to the power I theta, where r is the magnitude and the theta is the argument, like the argument of z or argument of w, then w star again will have e to the power minus I theta instead of e to the power I theta. And if you just multiply w and w star, you have r squared and e to the power I theta and e to the power minus I theta cancel each other to give a factor of 1. So eventually you get r squared, and r squared is the radius, like the distance from the origin squared. So that's the magnitude of w squared. Now the second part. So we have been given two equations. 5w star equals 1 minus 2I times z squared, where z is another complex number, and zw equals 10 plus 10I. Given that magnitude of w is 2 root 5, find z expressing your answer in the form a plus bi. So we have to find, so what we do here is we first multiply these two equations. So on the left hand side, we have 5 times z times modulus or magnitude of w squared, because we have w squared as we proved in part A. That is equal to 1 minus 2I times 10 into 1 plus I. So 10 into 1 plus I is like 10 plus 10I. I have just taken the factor 10 out. And then z squared is there from the first equation. So modulus of w is given. So you can just put in the value 2 square root 5 in place of that and carry forward. We get, so this becomes 2 square root 5. If you square it, we get 20. So 20 times 5 is 100, 100 times z on the left hand side. On the right hand side, you have 10. And then when you like multiply these two numbers, you get 1 plus 2 minus I times z squared. So as you carry forward, 10z becomes 3 minus I times z squared, and z equals 10 divided by 3 minus I. We are, of course, eliminating the possibility that z equals 0 here because we want the non-trivial solution. So you can just normalize the denominator to be a real number. So you multiply by its complex conjugate, 3 plus I, on the up, like numerator and denominator, and you get 3 plus I as the answer, because 3 square minus I square is just 3 square plus 1, and 9 plus 1 is just 10. So that 10 cancels with the 10 factored in the numerator. So that is 3 plus I, which means A equals 3 and B equals 1. So problem number 9, question number 9, the sum of the first 10 terms of a geometric sequence is given by Sn equals r from 0 to n minus 1, 5 times log base 2 of c to the power r. So this is the geometric sequence sum. Given that Sn converges, find the range of possible values of c. So we know a geometric series will converge only when the multiplicative ratio, the common ratio, has magnitude less than 1. So let's see what that condition gives us. So that means here simply the common ratio is log base 2 times c, so its magnitude has to be less than 1. So the range of values is, so log 2c, log base 2c can be lying between -1 and +1. So in that sense, now if we exponentiate these exponents for 2, we get c lying between half and 2. So that's the range of values. In part B, it says that in the case where c equals 1.5, so c lying in the range that we found out, find the least value of n such that s infinity minus sn's magnitude is less than 0.1. So s infinity, first of all, is 5 divided by 1 minus r, where r is the ratio, common ratio here. So this r is not the exponent that is given here. This r is the common ratio. And then we can also write the expression for a common ratio. I'll just write the ratio in the down line, second line. And then we can also calculate the expression for Sn up to the, like the sum up to the nth term, which is 5 times 1 minus r to the n divided by 1 minus r. Here r is actually log base 2 of c. So then we get S infinity minus Sn, its magnitude would be, so we have 1 by 1 minus r for S infinity and 1 minus r to the n by 1 minus r. So you get r to the n divided by 1 minus r. And of course, there is a factor of 5, factor of 5, factor of 5. So that gives me factor of 5 with modulus of magnitude of r to the power n divided by 1 minus r. So here we can just write 1 minus r instead of taking the magnitude, because we know that r is less than 1. Otherwise, because c is 1.2, which is 1.5, which is lying between 2.5, that is our allowed range where the sum will converge. So r is less than 1, so you can 1 minus r is positive. So then we have r to the power n equals 0.1. Well, so we are trying to reach that point when s infinity minus Sn equals 0.1. So that gives us this expression for n. You have to take log on the left hand side. If you take the log on the right hand side, you get log of 0.1 times 1 minus r divided by 5. This whole thing on the right hand side in the previous step. And then you divide by log of modulus of r because you got it in the left hand side after taking the log. So if c is equal to 1.5, we know the value of r. So r is log base 2 1.5. If you put that value and calculate this number, this comes out to be 8.936. So now if we go to n equals 9, then Sn and S infinity will differ from each other by less than 0.1, or their difference will become less than 10, less than 1/10. So here we come to the section B and the 10th question of this paper, which is the first section B's paper, asks about modeling of population in Canada from 2000 onwards. So the following table shows the population of Canada T years after the year 2000. So T equals 0, 5, 10, 15, and 20 means 2000, 2005, 2010, 2015, and 2020. And the population is given in millions, so 30.7 millions, 32.2 millions, 34, 35.7, 37.9 millions. Then it says that a student uses linear regression to model the population of Canada using this data, and the student model is P equals AT plus B. Write down the value of A and the value of B, and interpret in context the value of A. So let's just very briefly recap how linear regression works. So you have some data, first of all, like TI and PI, is pairs. In this case, TI goes from 0 to 20, and you have 5 data points. And you try to make a model of P as a function of time as AT plus B. So this is linear in time. And to find the best values of A and B, you fit these TI and PI values that are given using something called minimizing the mean squared error. So the mean squared error, or MSE in short, is defined as 1 over 2 times number of samples that you have. So then you sum over those samples and you calculate the difference between the actual value of population and the model fitted value. and then make a square of it. And if you take derivative with respect to A of MSE and take the derivative of B with respect to of the MSE and set them to 0, that will give the values of A and B that would minimize this MSE error or the mean squared error. So that would actually give A as a function of PI, GI, and B as a function of PI, TI. So in GDC, you can solve this and figure out the answers. So the answers are for A, it's about 0.358, and for B, it is 30.520. So you interpret in context the value of A. So A is nothing but the rate of change in population in millions per year. Each year, the population increases by 0.358 million. So this is for the modeled part. So when you're doing modeling of regression, linear regression using linear regression, according to the model, each year the population increases by 0.358 millions. So the student uses this model to predict the population of Canada in the year 2030, where t equals 30, and calculates a population of approximately 41.3 million people. Comment on the reliability of the student's prediction. So t equals 30 is out of the range of this range of 0 to 20. So the data that the student had, was from 0 to 20 of values of t. Now trying to extrapolate that to t equals 30 is not a great reliable prediction. So this prediction will not be reliable. So you can just write that, because 2030 is well beyond the range of the model. Now it says a data scientist uses additional information to develop an exponential model for the population. In this model, B of t is given by this equation, where B of t is the population in millions after t years from the year 2000. And this is valid for t between 25 and 100. So use Benoit's model to predict the population of Canada in the year 2100. So that is like t equals 100. So if we put t equals 100 in Benoit's model, we get 33 times 1.005 to the power 100. We put it into the calculator, it gives you 55.2 millions. Interpret in context the value 1.005 in Benoit's model. So here, if you look b of t as 33.5 times 1.005t. If I increase t by 1, like I go ahead by 1 year, then the population gets multiplied by the factor 1.005. So which means that the population increases by 0.5%. So that is the interpretation of this value 1.005, that the population increase rate over previous year is 0.5%. Okay, so the next parts, another data scientist Cecilia develops a third model for the population, and this is 62 divided by 1 plus e to the power minus 0.02t, represent the millions of people in Canada t years after the year 2000. And this is also applicable for t lying between 25 and 100. So use Cecilia's model to predict now the population of 2100. So you just put the value t equals 100 and you get 54.6 millions. Determine the year in which the difference between the predictions from Menard's model and Cecilia's model is greatest. So we can calculate b prime of t, or the rate of change of the Bernard's model's population, and c prime of t, the rate of change of the Cecilia's model's population. When they are same, those two derivatives are same, that means their differences, b of t minus c of t, is largest, or it has a maxima, where b prime of t minus c prime of t equals 0. You can plot these two functions in the calculator and find their intersection points to find the value of t. In this case, the solution is t equals 58. So in year 2058, their predictions are like differ by the largest amounts. Find the value of b prime 75 and c prime 75. So just put in the expressions that we got, b 70 equals 75 and t equals 75 for both b prime and c prime. And you get 0.243 for b prime, and for c prime you get 0.185. Compare and context in the context the values of b prime 75 and c prime 75. So we see that b prime of 75 is clearly a lot larger than c prime of 75. So this just means that the predicted rate of increase in the year 2075 is larger in Benoit's model than the Sicilius model. So question number 11, a line L is defined by these relations between x, y, and z. Find the equation of L expressing your answer in terms of a plus lambda b. So we need to find a vector-like equation of some constant plus some scaling factor lambda times another vector. So like that is the direction vector. So how can you do that? So you just solve for, so we just say that this scaling factor is lambda, and then we solve for x, y, and z in terms of lambda. And then we can just form this equation and zip them into a vector form to have 2, minus 4, 0. So the constant parts 2, minus 4, and 0. So these will come as the constant vectors, and the scaling factors that are multiplied. So negative 2, 1, and 3 will become multiplied by lambda. So this is in the form a plus lambda b, where a is this vector and b is this vector. Next, it asks, determine the minimum distance from the origin O to the line L. So if I have a point on the line L that can be represented as 2 minus 2 lambda, lambda minus 4, and 3 lambda, as we found out in the previous um, part. So then we can just take square to find the squared distance from the origin and take a derivative and make it like push it to 0. So this is the simplified form, 14 lambda square. So here you get 4 lambda square. Here you get 1 lambda square 5, and here you get 9. So total 14 lambda square. And then there is negative 16 lambda. And so 8 from here, 8 from there. And then for the constant term, you have 4 plus 16, that is 20. Now, if you take the derivative, you get 28 lambda minus 16. If you set it to 0, then lambda becomes 4 over 7. So when lambda equals 4 over 7, at that point in the line L, that point is as the minimum distance from the origin. Now, of course, if you take the double derivative to check for this is maximum, you get 28, so which is greater than 0. So this is indeed, S square is indeed minimum. So S minimum squared is calculated as 108 by 7. So if you put the value of lambda in this expression for a square, you'll get S minimum squared. So in the next part, it says that a plane pi is defined by this linear equation 6x minus 3y plus 5z equals 24. Verify that pi contains the line L. So if we put the point x, y, and z as the x, y, and z coordinates for the line L in terms of lambda. So 2 minus 2 lambda for x, lambda minus 4 for y, and 3 lambda for z. And we do find that the entire thing is independent of lambda. Here it turns out that way. If you just break out the terms, 12 minus 12 lambda minus 3 lambda plus 12 plus 15 lambda. So there is a plus 15 lambda and negative 3 lambda, negative 12 lambda. So together they cancel each other and you get 12 plus 12 equals 24. So indeed this equation is satisfied. 6x minus 3y plus 5 is equals 24. So hence the line L, all the points in the line L will be contained in the plane pi, and hence the entire line is contained in the plane pi. In the next part, it says that a second line M is parallel to pi. The line passes through the point 4, 1, 2, x, y, and z coordinate and intersects the z-axis. Find the equation of M expressing your answer in the form S equals C plus mu D, like before here. So the direction vector of M, of the line M, that gets scaled with a factor like a lambda, that has to be the difference vector between 2 points that the line goes through. So the line goes through 4, 1, 2, and it intersects the z-axis. That means it goes through 0, 0, and some z0, which I don't know yet. That is the generic coordinate for all the points in the z-axis, and it goes through one of such points. So their differences is form this vector. Now M is perpendicular, the line M is perpendicular to the normal of the plane pi. So the normal of the plane pi is 6 minus 3, 5 vectorized form. From here, we get by substituting this form of M, we get 24 minus 3 plus 5 times 2 minus z naught, which is 31 minus 5 z naught. Now, if they are normal, then this term, the dot product will be 0. So this is the dot product, and if it is 0, then z naught equals 31 by 5. So just applying the fact that M is perpendicular to the normal of the plane pi, we have found out the unknown that we were looking for, which is z naught. So we can now start to construct an equation like M equals C plus mu times some vector. So the direction vector now here is 20, comma 5, comma negative 21, with C equals 4, 1, and 2. And this comes out as follows. So we did mention that M is proportional to this vector. So 4, comma 1, comma 2 minus 31 by 5, which is proportional to 4, 1, negative 21 by 5, which is proportional to 2 multiplied by 5, 25, negative 21. So that's how we get this vector 25, negative 21. And since it goes through this point 4, 1, comma 2, then we can just write it as C plus mu times D. So question number 12, this is the last question of section B and this paper. So it asks, a curve C has equation y equals 2x squared plus 6 minus 6x minus 3 divided by x plus k where x is real and x is not defined in x equals minus k, where k is a real positive constant. So that dy dx is this. So the first part is not so difficult. You just have to take the derivative of the functional form. So let's do that. So dy dx can be written as this using quotient rule, x plus k whole squared in the denominator, then x plus k times derivative of the function in the numerator, which is 4x plus 6 minus 2x squared plus 6x minus 3 times derivative of x plus k, which is 1. So after simplifying this, you will get the terms that are shown in the question A. Find the range of values of k for which a local minimum or maximum point exists. So for this also, you have to consider the derivative because you want to find the numerator to go to 0. Where does it go to 0 as a function of x? So we have from this like completing the square of this expression. So we have 2x squared plus 4kx plus 6k plus 3. We take the factor 2 common, and within that we have x squared plus 2kx, and we take another k square. So we take an extra 2k square, we do like take also subtract the same and keep the rest of the terms that was not used. So 6k plus 3, and this has to be 0, or in other words, x plus k whole squared have to be equal to 2k square minus 6k minus 3. And this one has to be greater than equal to 0. Why? Because x is real and k is a real positive number. So their sums squared will also have, which is equal to this, will have to be greater than equal to 0. So that gives us this inequality, and we can solve this inequality. The critical points of k for this equation, where if we set 2k square minus 6k minus 3 equals 0, are these 3 by 2 plus or minus square root 36 plus 24 divided by 4. 36 plus 24 is 30, and 20 is 50, and then 10 is 60. So 2 square root 15, and then you have 4 at bottom. So this is 3 by 3 plus minus square root 15 by 2. So k has to be greater than equal to 3 plus square root 15 by 2. So k could have been less than 3 minus square root 15 by 2, but 3 minus square root 15 by 2 is negative, and it says that k is a real positive number. So the allowed values of k are 3 plus square root 15 divided by 2. Part C, write down the equation of the vertical asymptote. So in this equation, if we take k equals 2, if we take k equals 2, this would be 1 over x plus 2 factor in the denominator of y, and then the other terms in the numerator. So this has a pole at x equals minus 2. So at x equals minus 2, this would just go to positive infinity straight up. So x equals minus 2 should be the answer at the vertical asymptote. So that's there. Then it asks to find the equation of the oblique asymptote. So let's see that. So we are trying to find when x goes to infinity, how does the function behave? So when x goes to infinity, we can divide this 2x squared plus 6x minus 3 in the numerator term by x plus 2 to get 2x plus 2 and plus some term that will go to 0. So let's work this out. So we have 2x times x plus 2 plus 2x minus 3. But this minus 3, I can write it as plus 2 minus 3 divided by x plus 2. So this gives 2x plus 2 minus 7 over x plus 2. Now, if you take limit x going to infinity, this term will go to 0, so it will not contribute. Only these two terms will be relevant. So this would be the oblique equation. So the function y will diverge like a straight line as x goes to infinity to x plus y equals to x plus 2 on both sides, actually, plus infinity and minus infinity. Then it asks to show that dy dx is greater than 2 if x is not equal to minus 2. So let's see that. Dy dx is, as we have derived before, can be written as, so this 2x square plus 4kx plus 6k plus 3 can be rewritten in this form, again completing the square and keeping the other terms. So here we have, when we divide by this fraction x plus k whole square, we get 2, and then we have plus some function of k divided by x plus 2 whole square. Now, if we here we have put k equals 2. If you put k equals 2, then this is negative 8 plus 12 plus 3, which is equal to 7. So this is 7 by x plus 2 whole square. Now, this is a positive quantity. So it is true that the dy dx is greater than 2. Alright. Then the last question asks, sketch the curve C showing clearly both asymptotes and the general behavior of C as it approaches each asymptote. So as we found out that at x equals negative 2, y would go to infinity straight up, and at x goes to infinity or minus infinity, it would go as 2x plus 2. So if we combine those two properties, we can sketch the graph this way, following this. So here note that at x equals negative 2, there is an upward and downward uh, divergence or asymptotes going to plus infinity and minus infinity. And as x goes very large, then this is 2x plus 2 straight line. So this is like a 2x plus 2 straight line, but bifurcated by the divergence at x equals minus 2.